In this lesson, we're going to learn about special right triangles. So we know a lot about triangles, but there are two triangles in particular that are special because of the relationships between the sides and the angles. So in this activity in class, you'll start out with your square and you'll draw a diagonal, and we don't have a protractor to measure it right now, so I'll just tell you that in a square we know all the angles are 90, and when I draw this diagonal, that turns this into a 45, 45, 90 triangle. And that's the first type of special triangle we're going to talk about. So in the class lesson, we would put you into groups and have you pick a length for your leg. So for example, I pick 5 for my 2 legs because both sides are the angles are the same, so the sides are the same. Now when I do the Pythagorean theorem to find out my hypotenuse, I do 5 squared plus 5 squared equals c squared, which gives me 50 equals c squared. So when I take the square root of 50 to figure out what c is, I break it down just like we simplified our radicals. I'd say 5 times 10, and 10 is 5 times 2, so I've got a pair of 5s, which makes the hypotenuse 5 times the square root of 2. Now ideally in your groups everybody would pick a different number, so let's say someone else picked 7. And they did the Pythagorean theorem and found out their hypotenuse was 7 times the square root of 2. And the next person might have picked 10, and guess what? Their hypotenuse would be 10 root 2. And another person, maybe they just wanted to be different and picked 18. Well, guess what their hypotenuse is going to be? 18 times the square root of 2. So there's a special relationship between the legs and the hypotenuse of a 45, 45, 90 triangle. So I made a table for us to kind of document that. And what you'll see on your formula sheet is going to remind you that in this 45, 45, 90 triangle, this leg would be, let's say, x, and the other leg would be x. In your 45, 45, 90, the two legs are the same length. And your hypotenuse is going to end up being x root 2 every single time. So that's the relationship you want to remember. So it's pretty easy. If I tell you one of the legs is 13, you would tell me, well, the other leg must be 13. And according to my rule here, the hypotenuse would be 13 root 2. So that's the simplest one. What if I gave you the hypotenuse was 20 root 2 and you had to tell me the legs? Well, according to our rule, if the hypotenuse is 20 root 2, the x part of that is the 20, so the legs would both be 20. Still pretty easy. Now, what if I told you the leg was 6 root 2? And I asked you to find the other leg and the hypotenuse. Well, first off, we know the other leg is the exact same thing, 6 root 2. But how would I find the hypotenuse? Well, if I need to go from a leg to the hypotenuse, look what I do. I just take whatever the leg was times the square root of 2. So that's what we'll do here. The leg times the square root of 2. So 6 root 2 times root 2. Remember we talked that the square root of 2 times the square root of 2 is just 2. So 6 times 2 is 12. If the legs are each 6 root 2, the hypotenuse is 12. You can put that into your Pythagorean theorem if you want to, or easier if you just learn the relationships in this triangle, and you can do that without even a calculator or the Pythagorean theorem. What if I did something weird, like this one is 3 root 7, and you had to pick the other two? Well, the first leg is also 3 root 7 because in a 45, 45, 90, the legs are always the same. How would I get the hypotenuse? Well, my rule tells me x times the square root of 2. So it's 3 root 7 times the square root of 2. And when I multiply those together, I simply get 3 root 14. Looks like a weird answer, but that's what you do. The leg times the square root of 2 equals the hypotenuse. So that's one relationship you want to remember. Now, what if I told you the hypotenuse was 24 and I asked you to find the legs? All right. Well, I know the hypotenuse is the x root 2 part. So how do you suppose I get from x root 2 to x? Let's take a look. Hypotenuse equals x root 2. How do I go from here to just x equals? Well, I'm going to divide by the square root of 2 on both sides. And that's going to give me x equals. And if you'll remember, in our last lesson we talked about how do I simplify when it has the square root of 2 on the denominator. So here's the paper from last lesson. If it was 8 divided by the square root of 2, we multiplied top and bottom by root 2, and we ended up with a simplified answer. So let's take a look at this one. I'm going to multiply by root 2 over root 2. And that's going to, I'm working sideways here, that's going to give me 24 root 2 over the square root of 2 times the square root of 2 is just 2. And then notice what happens here. 24 divided by 2 is 12, and there's my answer, 12 root 2. So there's a little shortcut in there. If you look at it, look at what we started with. Our hypotenuse was 24, and our leg ended up being 12 root 2. So if you notice, well, it's just 24 divided by 2 is 12, and then times root 2 gives me my leg. So if I know the hypotenuse, I divide by the square root of 2 to get the leg. So that's the other relationship you want to remember. You can go through this process every single time, or if you just remember this shortcut, the hypotenuse was 24, so the leg was 12 root 2. I'll throw one more in for you. What if the hypotenuse was 30? Without doing any of this work, what would the leg equal? So just look at the shortcut. I went from 24 to 12 root 2. So if the hypotenuse was 30, I think the leg will be 15 root 2. So you divide by the square root of 2, divide by the square root of 2, and then we multiplied by, we divided by 2, and we multiplied by the square root of 2 to get our answer. 30 divided by 2 was 15 times the square root of 2. So I encourage you to learn that little shortcut. It will come in handy. Next up, we've got the 30, 60, 90 triangle. So this one started with an isosceles triangle. An isosceles triangle, all the sides are equal. And if I draw an altitude right here, it cuts the bottom in half. So this is a 60-degree angle, and this is a 30-degree angle. That gives us a 30, 60, 90 triangle. And then we'll get the relationships from this on the back. So if you were in a group, we would have had you pick some numbers for this, and I'm just going to go straight back to my chart. 30, 60, 90 triangle has a short leg, a long leg, and a hypotenuse. So here's the short leg, here's the long leg, and of course the hypotenuse is across from the 90. The short leg is across from the 30-degree angle, the long leg is across from the 60-degree angle. And here's the relationship of these sides. The short leg we're going to call x. The long leg is going to be x root 3. And again, this is all in your formula chart, so you have it for reference. The hypotenuse is 2 times x. The hypotenuse is twice as big as the short leg. And if you look at this picture, this bottom side is the same length as GH. So when this altitude cut it in half, FG is going to be half as much. FJ is going to be half as much as FG. All right, short leg, long leg, hypotenuse. So we'll start with a couple of easy ones. Short leg is 6. Then you just fill in the other 2. Long leg, 6 root 3. Hypotenuse, 12. So if we've got those relationships worked out, then that part's easy. Let's give you another easy one. Long leg is 5 root 3. So now we need the short leg and the hypotenuse. Well, the long leg is x root 3. So if it's 5 root 3, then the x part's just the 5. So 2x would be 10. Okay, still keeping it pretty simple. So I could give you a hypotenuse of 18 and then ask you for the short leg and the long leg. Well, notice the hypotenuse is 2 times x. So 18 divided by 2 is 9. And the long leg would be 9 root 3. So notice in any of these situations, if I don't give you the short leg, the first thing you find is the short leg. Because if you know the short leg, you can find everything else. So in the simplest, short leg times 2 is the hypotenuse. Short leg times root 3 is the long leg. So if you always go back and start with your short leg, then you can find the others. Now the tricky one comes if I give you the long leg, but let's say I tell you the long leg is 12. Well, the long leg is supposed to be x root 3, but I gave you 12. So what do you suppose we should do to solve for x? I think I should divide by the square root of 3. These will cancel and I just get x equals. X equals 12 divided by the square root of 3. I'll reference you back to the last lesson. When I had 15 divided by the square root of 3, I went through a process. Multiplied by root 3 over root 3 so that I could rationalize my denominator. So we're going to do that here. If I multiply by root 3 over root 3, I end up with 12 root 3 over root 3 times root 3 is 3. And then 12 divided by 3 is 4. So if x is 12, if the long leg, x root 3, is 12, then my short leg ended up being 4 root 3. Now, do you see a little shortcut there? Notice we've got a root 3 here, so what happened to the 12? I divided by 3, and I multiplied by root 3. You are welcome to go through this process every time, but if you want to catch the shortcut from here to here, I encourage you to do that because that makes it simple. Once I know the short leg, how do I get the hypotenuse? I just multiply by 2. 4 root 3 times 2 is 8 root 3. So if I give you the long leg, you take the long leg divided by root 3 to get the short leg. And this one has the shortcut of dividing by 3 and multiplying by root 3. That's how we got from 12 to 4 root 3. All right, what if the long leg was 21? Remember what we did in the previous question. Divide by 3, multiply by root 3. If the long leg is 21, my short leg was 7 root 3, and my hypotenuse is twice as much as my short leg, is 14 root 3. So you'll want to keep your formula chart with you, so you've got these two pictures of your special triangles, the 30, 60, 90, the 45, 45, 90, because they will come in handy. I'm going to go through some of these examples with you. I think I might make a separate video for these examples. And so tune into the next video and I will go over this page called Elaborate.